So you haven't missed anything, right? Um, so I always quite the bottom point, which effectively is, it's a great opportunity for everybody. I also work on an open source project called Brighter. It's not very relevant to this talk, but if you ever wanted to work on an open source project around events and messaging frameworks in .NET and in Python, we're always looking for new contributors. Please come and check us out. All right, so what's today's agenda? I wanted to really look at a number of the key criteria that Fowler and Lewis raised for microservices and explain how they work a bit more and give you a better idea of how to partition microservices. So first of all, I wanted to look at this idea of products, not projects. And the reason for doing that is to give you an understanding of what are the criteria that we set for how we should partition. What are the results that we want from our partitioning? And products, not projects, is really what we're trying to achieve. Then we're going to want to look at this idea of componentization via services. So we want to look at what is been the history of our attempts to break up our software into components, and what can that tell us a little bit about what we should be doing here. Then I want to get into the meat of the talk for many of you, which is how we organize around business capabilities, and I'll be showing you a couple of techniques to find them, including value stream mapping and event storming. And finally, we'll look at this idea of independent operability, which gives you some kind of hints around how you can use the information you've been given in the third section of the talk. All right, so let's talk about this idea called products, not projects. And what we were really talking about is we're saying we want our teams to basically focus on delivering a product, not on focusing on delivering a given project. And really a lot of this comes back to people like Adrian Cockcroft, who used to be the architect at Netflix. And when he was there, Adrian pushed the thing that he called at the time fine-grained SOA, which we'd recognize nowadays really as being microservices. I mean, he said that delivered this classic line, speed wins in the marketplace. And Adrian's point was that the table stakes for the number of releases you should be doing in commercial software had moved to several times a day. And that if you were still working on a principle of releasing once a month, once every quarter, you were now way behind what your competitors were doing, and they would essentially out-deliver you on features in the marketplace while you were, sitting there effectively waiting for your next 6-month release cycle to hit. And the reason he mentioned that is because of this problem, which I'm sure many of you have experienced. When we tend to work in the world of monoliths, we quite often have a single repo in our source control system of choice. Let's say it's in GitHub. And as soon as we begin to scale towards multiple teams, because we want to try and go faster and deliver more to our customers, we hit a problem. And that problem is that it gets very difficult for us to all play in the same sandpit. You're checking in something, I'm checking in something, and we're both working on the same pieces of code with different agendas in our different teams, probably different parts of the project that we've been asked to work on. And so what we tend to do is all say, well, this team at least is going to basically branch, and we're going to work on our own branch separate from all the other teams. And when we want to come and release, we'll take that branch and we'll merge it back into master, and we'll create a release candidate. And that release candidate then we'll basically test, and then we'll ship that out basically to our customers. And for a reason that is circular, and I'll explain in a minute, what tends to happen is we say something like, all right, well, we're going to basically get a release out on the 15th. We've got our work, and it's kind of done. And other teams say, oh, we'd like to go out on the 15th as well. We've got some work that we'd like to push out at the same time. So we hold a release meeting, and the wise councils appear and they talk about what should be in this release and what shouldn't be in this release. And we come up with essentially what we think is in the release candidate. Everyone merges their code in. Then we go through usually a couple of days of pain while we fix basically the issues that result from us actually trying to merge everybody's given branches. And so, 2 days into this process, we eventually start testing. And when we start testing, we hit the problem that effectively that there are usually defects. The usual estimate is given there's something like 30% of what you've done needs some kind of rework, right? And if we've been working for about 10 days or something, that could be about 3 days of rework. But across a number of teams, it may not be possible to parallelize that effort. Anyway, what happens is basically all of our teams essentially go and say, well, we've got rework to do. And quite often there's this problem I call pin the tail on the donkey, right? What happens is we're doing some regression testing, something breaks, it's not clear who broke it. So we have some poor individual who sacrificed whose job is to go in, debug the code, figure out what broke, and then go to the relevant team and say, hey, you broke stuff, can you fix it? We all wait for their fixes to come in. We end up going to morning triages where everyone comes up with a bug list and they're saying, which ones of these can we live with? What has to be worked through? We may get to the point where somebody says, I really have to be out by the 24th. I have commitments with marketing and my customers. And someone may have to say, well, we need to roll back this set of features out of the release now because it's clear they're not going to be ready. Maybe we've got feature switching. Maybe we can turn off some of those branches of code. But generally, my experience is this whole cycle can often take us a couple of weeks. And the problem with the cycle taking a couple of weeks is we're now effectively, at best, releasing once every 2 weeks. And the problem is this becomes a self-fulfilling prophecy. Because I'm only going to release once every 2 weeks, I want to get into that release. Otherwise, I'm potentially waiting 4 weeks before I can get my software out. Because if I miss the getting into this release train, I have to wait 2 weeks to get into the next release train, which in itself will take 2 weeks to deliver. So that quickly means that I'm essentially always trying to push to get into releases with kind of not necessarily finished code, which essentially exacerbates this trap and the cycle we get into of taking 2 weeks. Right? And it turns out this seems to be really hard to break. And so what people had said was, well, maybe we need to move away from this idea of everyone working in the same sandpit. Couldn't we actually split up our software into a series of individual services so each team has no deployment dependencies on any other team? Now we really only have to worry about problems within the team itself. The team can effectively create feature switches around key elements of their software that they want to release, so that when a story is finished, someone can just push the button and release with the feature which is turned off for the other items. And because I'm no longer negotiating with all the other teams, I can release as fast as I can push stories out and get them retested, right? And so that's how we actually go faster. And when people began to talk about microservices early on, it was this that was the key objective they were seeking, was to go faster by allowing us to scale our organization. And that's why early on people said, if you only have a single team, you might as well stick with a monolith because you won't see the advantages. Now, it's a couple of key ideas here. One is it's still possible within a monolith to be distributed, right? If what you're seeking is distribution because you want independent scaling of some parts of your application from other parts, or essentially you want to work with smaller components to reduce the complexity and overhead of what you're dealing with, that can still be a monolith, right? You can use shared database integration techniques, you release the whole thing as one. Being distributed is not a forcing function towards going to microservices. What forces you to go to microservices is the need to scale your organization to have multiple teams, and each of those teams needs to have independent deployability from any other team. It's independent deployability that we're seeking as the key objective in this microservices model that's focusing on speed of delivery as the way we want to achieve stuff. Now, we do get certain other benefits from microservices. We also get certain other costs from microservices. And we need to be careful about the fact that we're not saying we don't gain other benefits from being in microservices. But the driver needs to be about saying, in order to scale my organization, I need to increase the number of things that I can ship independently of each other in order to allow those teams freedom of movement. What we end up with is something we tend to call product mode as opposed to project mode. So in product mode, an individual team owns basically a microservice, and that microservice has a backlog, and that backlog is controlled by a product manager. What the product manager is seeking to do the whole time is to improve certain measures that we have for that given microservice. So they may have given KPIs that may say, etc. We want to increase the number of customers that we can upsell to when they're ordering from our site, etc. Right? And each team then prioritizes their backlog of work depending on those key performance indicators, and they can work through that backlog and ship their microservice independently of anybody else. So imagine, which is a common example I use, we were working on some kind of hotel software. We might be working on effectively something like the front desk system as our microservice, and we might have key measures around things like reduce the amount of time it requires to check in a new guest, reduce the amount of time it requires to check out a new guest, right? Make sure that effectively when we get a new guest in front of us, we can upsell them additional hotel services. And those are the key items we are working through, as opposed to project mode, when essentially it's a system-wide effort which somebody's coordinating that requires the release of a number of components at the same time across multiple teams, which slows us all down, requires coordination, requires some people to ship first with features turned off because somebody else can't ship yet and they can't turn their feature on, etc. All that coordination. And there's a rule of thumb which says really we should be spending 80% of our time in product mode, or we can be truly agile in product mode, and about 20% of our time in project mode, where we drift much more back towards a waterfall feeling. And if you find your organization is constantly in project mode, it's because you've not really realized microservices properly, if you've done that, or you're still in a monolith. But if you've not really realized microservices properly, what you can find is you're in project mode, even though you ought to be in product mode. And there are a couple of reasons for that. One of them is this nanoservices problem. So your unit in which you have essentially partitioned your microservices is too small, and any real work actually requires you to release multiple microservices, thus pushing you back into project mode and making you lose some of the benefits of agility. Right? The other problem could be essentially that you are too large and you have to have multiple teams actually working on one microservice, right? So then in that case, you've effectively become too coarse-grained. So you want something in the middle, which I quite often call a kind of Goldilocks service. You want to be just right? Not too big, not too small. And the question is how you get there. How do you find that Goldilocks zone for microservices? All right. So let's kind of go back a bit, having given a kind of idea of what we're trying to achieve. We'll talk a little bit about the history of the componentization of our services and understand what we may be able to learn about how that's worked in the past. So one of the things that I did years and years ago was work as a COM programmer in C++. And there was a certain point in history when we were building kind of client-server systems and we wrote COM components that ran essentially as part of a fat client, and the client was written something like Visual Basic or Power Builder. These were the days when Visual Basic was king because you could quickly spin up a new UI, and a lot of the crazy business logic was then written by C++ devs and exposed by COM components. And COM was essentially a binary interop standard. You had an interface definition language which described essentially in a platform-neutral format what your exports were, and then you could use that essentially as a client to query for capabilities and make calls. Any system like that, any kind of binary interop like COM, is also usable basically as an RPC system. So what happened was things like DCOM emerged, right? So DCOM was a way of saying, well, rather than running my binary COM component as part of my process, I'm going to distribute it to another computer, and I'm going to talk to it there. It's going to be a remote call. And that's going to allow me to scale out. And that became, as we moved away from client server, more towards this kind of end-tier model with an application server. The trouble for developers working in the Microsoft world with this idea of componentization, where we had these functions that quite often they had to be larger than classes, but they were reasonably small, was that DCOM was a beast. DCOM was a beast because it was really difficult to get it working and get your security correct. It required a number of ports to be open. That wasn't really exactly clear which ports you had to get opened. And so what tended to happen in most environments was you simply ended up opening every single port on the machine in order to get DCOM working. And there were lots of complaints really about this idea of getting DCOM working. And at the time, some of you are old enough like me to remember, was a really important voice in amongst the COM development community. Later at Microsoft, initially outside Microsoft in a training company called Don Box. And Don essentially was looking at some way of improving how this DCOM experience worked for developers. So what he said was, well, port 80 is always open because that's where HTTP travels on. So what I could do is take the call and essentially just make it a name of a method and a series of parameters, put that in XML, put that in the body of a HTTP post request, listen to that on the server, take the post request, make the call to a component running locally in process there, get the results, turn them back into XML effectively and put them in the response from the post. And on the client side, take that post value of response essentially and marshal that back into the client so that the client looks as though essentially it's made a remote com call, but it's just doing effectively an HTTP post over to make that happen. And because this worked and was very easy, he called this the Simple Object Access Protocol, or SOAP. And SOAP really took off, and it created this web services revolution. The idea that we could create components that would run remotely very easily using HTTP, and this idea of web services evolved, right? So this was basically led to the growth of what we call service-oriented architectures. The idea that we can split up our system into a series of components that were running on separate servers and talk to each other via SOAP. The problem we quickly hit with SOAP is that we hit the problem of too much granularity, too many of these services talking basically HTTP in very chatty interfaces, all interconnected. You changed one thing and that had a huge ripple effect across a number of the web services. And we suffered from these things called temporal coupling. You have to be up when I call you, and behavioral coupling. I know too much about all these interactions, and I get all the interaction logic bleeding out into the caller from the service. And SOA2 came along as a fix, and in SOA2 we said it's going to be much better if we go asynchronous. If we actually send events between more coarse-grained services, that's going to work better for us as a model. We need to focus on processes as a target what we want to automate. SOA2 got kind of derailed, and it got derailed because the vendors came along and they said, this SOA thing is really popular, how am I making money from that? And the answer was the enterprise service bus. If everyone's going to events, then I can do something which initially is a positive idea. I'll basically make some means for you to talk to legacy systems that don't have event-based architectures, and what you'll do is essentially raise an event and I will make a post to their HTTP interface because they're still the old web services I just built in the last iteration of what was going to fix computing. And then they began to say, well, actually, if I've got essentially the controlling the interaction through my service bus, I can run workflows. And what happened then was you got externalization of the business logic that had previously been kind of in these calls, then now clustered into the actual enterprise service bus. And at first this looked nice. Everything looks clean. I haven't got this chaos. But in fact, the chaos was still there. It was just basically now firmly locked into a vendor-owned enterprise service bus, which is hard to get under test, almost impossible to move away from. And my personal experience of these is BizTalk from Microsoft, which looks like a very attractive set of tooling, has lots of things for mapping between various formats, etc. But as soon as you get into the world of running code in BizTalk to actually control the business process, becomes a bit of a nightmare. So along comes a guy called Jim Weber, and Jim Weber, who now works for Neo4j, at the time was at ThoughtWorks, created an idea called Guerrilla SOA. He said, you know, we should really throw away enterprise service buses because that's really just led us down to a dark path. What we actually want to do is just build reasonably coarse-grained services that communicate with each other over lightweight protocols such as HTTP or something like RabbitMQ. And that really became what we think of as the smart endpoints and dumb pipes constraint on microservices. And then along comes James Lewis, and then later with Martin Fowler and a few others, and they meet together and they discuss and they pull together these new ideas for doing SOA alongside things like DevOps and DDD, which have emerged since the first SOA, and they create microservices. So why is this history interesting, right? Why am I telling you the history of microservices? I'm telling you the history of microservices because we'd already figured out in this componentization via services approach a lot about how to build services successfully. And microservices don't really change that. They can be thought of as SOA3, or even some people would think about it as a more constrained SOA style. But a lot of that SOA advice still applies. So what particularly what we want to take away from that? Well, I would still tend to wander back to the four tenets that Don Box created, and I know that they have not necessarily always been in favor with architects over time as a way of describing what a microservice is. But I think they're very useful as the baseline for the constraints that our service ought to obey. So the four tenets are that boundaries are explicit. What we mean by that is any interaction with our services by some form of API. Now, the API could be HTTP, but it could be gRPC. But it can also be messaging. It can be AMQP. You could be talking to SQS and AWS, right? The protocol is not necessarily important. What's important is that we have a contract, and that contract, the API, is what we say is stable when we expose to other services. And this led to the ideas like contract first or later API first. And there's the famous Jeff Bezos email at Amazon in which he says essentially you must have an API and no one can talk to your internals like your database. And services are autonomous is essentially the pair with this. This says I must be able to deploy my service without any other services being deployed at the same time, right? So I must have no coupling to other services. The key idea here is I own my own data in a database. Nobody else can write to it. The only way you can write to it or read from it is through my API boundary, through my contract. That means I can change my implementation because as much as I want and iterate as a team, right? And if the contract remains the same, nobody else cares. You also look at share schema by type. Share schema by type is to do partially with avoiding platform coupling. The other stuff might be written in an entirely different language. It's also a little bit that if we share schema by type, we can implement things like Postle's law and make sure essentially that consumers won't break if we just do something simple like adding a new field. Effectively by policy is not so relevant to this talk, but that's saying we have to agree that I talk HTTP with OAuth, and that's how you communicate with me. Otherwise, essentially, we're going to have a set of competing protocols that we can't talk to each other. So in order to achieve our goal, which we described earlier as products, not projects, what we need is to have common closure for our microservice, such that the product manager for a given team can have a backlog which applies solely to that particular microservice and doesn't require them to change other microservices. And we can think of this idea as common closure. The idea that the things essentially that are together are effectively open to the same forces of change and closed to other forms of change. Now, given that essentially we have said that our microservice follows the SOA tenets, and we think of it as something where effectively we have a interior that is protected from the outside by a contract in the form of an API to allow us to be autonomous, we create the situation that our microservice does create dependencies to other microservices based on that contract. So in order for us to move independently from other microservices, we need to have stable contracts. Because if the contracts our microservices expose are not stable, we won't be able to get to this world where we say, I'm going to create some change and just release my microservice, and I shouldn't be releasing all the other microservices. And the problem essentially with nanoservices, and also the problem really a lot with synchronous microservices, kind of SOA1 era style, which has come back in the world of gRPC and HTTP-based microservices, is that we quite often find ourselves on unstable foundations. In order to change anything, to do essentially, I probably end up changing APIs, I'm introducing new APIs, and it turns out that I'm actually releasing 4 or 5 microservices at once. And that's not what we were seeking. What we were seeking was we had one force of change, common closure for our microservice, an independent backlog. We were mostly doing independent releases about 80% of our time, and only about 20% of our time involved us coordinating release to other people. So how do we get that? How do we get a boundary for our microservice that allows us essentially to independently evolve and lower the amount of change that we basically force on other microservices? So Larry Constantine once essentially said that a structure is stable if its cohesion is strong and its coupling is low. And we talk a lot I talk a lot in other talks about this idea of low coupling, right? So if you go and see me talk about event-driven collaboration at other NDCs, you can find the video out there. Event-driven architectures being asynchronous, a lot of these can give us low coupling. They reduce our temporal coupling. You don't have to be up when I call you. They reduce our behavioral coupling. I don't know much about you. I publish a message. Maybe you consume it. I don't know what you do with it, right? And we can reduce a lot of our coupling. But the other side of that, if you want to have strong cohesion, in order to be stable, we need to have strong cohesion as well as low coupling. And the way we get strong cohesion in microservices is to follow the constraints that apply to microservices of being organized around business capabilities. So, the constraint that Fowler and Lewis raised was a microservice approach to division is different. We split up into services organized around business capability. And it's interesting, right? Because this was put out right at the beginning of the era of microservices. And not a lot of people really ask the question, what does this mean? And if you go away and start talking about business capability, you end up in the world of business architecture, etc. And it's, for many people, it's kind of black art. People don't really know much about it. People don't even necessarily know what the phrase is for business capability. You ask people who are microservice practitioners and you say, what's a business capability? And they kind of shrug, right? People start talking about bounded contexts instead. They say, oh, well, a microservice is aligned to a bounded context. We'll point out later why that's a nonsense. But effectively we say, look, what is the business capability? What is this thing that they were suggesting was the unit of alignment? And the thing is, the reason I raised the history of SOA a little bit, right, is because people who came from an SOA background understood this requirement, because SOA had always been organized around business capability. So that made perfect sense to them, this constraint. But people who've not been doing SOA for years and coming into it just kind of glibly ignored that phrase and didn't understand it actually referred to a whole body of work. And there's a quote here from Nikolai saying, a service should represent self-contained functionality that corresponds to a real-world business activity. And the idea is that if we are seeking cohesion for a microservice, we can find cohesion by looking at what we are modeling, finding the business processes, and using those as the partition boundaries for our microservices. Because quite often, we have mature business processes that we are mature businesses that we are modeling, and the processes have become quite stable over time, and those represent quite coherent things to target. And because they are coherent, they therefore essentially have high cohesion, and along with techniques around low coupling like events, will actually enable us to get the benefits out of microservices by doing products, not projects. Okay. So I talk a lot more nowadays about processes rather than capabilities as being the targets for modeling. And the reason for that is simply that a process is usually a verb plus a noun, like make lunch or prepare bill. And a capability is a noun like catering or accounting. And the capability is how we deliver a given process. And it can include people, tools, technology, organizational structures, etc. Right? So capability says, what is it that our organization uses to effectively offer lunch? Right? There are some staff, there's HR probably involved in looking after the staff, therefore there's some logistics at the organization, which may be basically getting the ingredients in, that kind of thing, etc. Right? And some part of that is the process of making lunch. The actual steps that are required, the various activities and tasks. And a given capability might actually offer a number of processes. So our catering capability might offer make breakfast, make lunch, and make tea. It may be NDC Oslo, we have continuous food, right? We wish. So the difference between a process and a capability is just that the capability includes the microservice we're building, we're automating a process. but the process is a better target for us to think about when we're thinking about microservices. So the question might be, how do we find our processes, right? How was I, as a software engineer, told to basically break up the monolith into microservices, and recognizing that I need to get the partition boundaries kind of right? How do I find the processes that I'm supposed to be aligning these things to so that I get effectively stable microservices that are have low coupling and high cohesion? So I talk about a couple of techniques. Pick whichever one you think is best for you, right? So one way to do it is to go and look at value stream mapping. So value stream mapping, particularly big in industry. It's how we look at efficiency in our car manufacturing plant, and often used essentially to look for waste, right? We're trying to eliminate waste from the process and say, how can we make this more efficient? Where have we got waste? And things like Six Sigma are very big on value stream mapping. We're probably interested in what some people call sometimes non-traditional value stream mapping. And that means that we're just using it as a technique in order to define processes, but our goal is not the traditional process of value stream mapping, which is basically to remove waste from a process and improve it. You can get into, so back when people were doing a lot of SOA, what happened was when they started to get into basically capability mapping, they also then triggered off business process re-engineering. And the reason they triggered that business process re-engineering off is because that's the first time anyone in the organization had said, we should figure out what the business processes are, and they'd effectively encountered lots of waste as a result of doing that. So SOA efforts were often tied to business process re-engineering efforts. From our point of view, probably, we don't necessarily want to boil the ocean, so maybe we're going to just use it in a non-traditional sense of using it for process discovery. So traditionally, in some kind of value stream mapping exercise, we have a kickoff, and in the kickoff, we agree what it is we are actually going to try and map. When we're mapping a value stream, we don't want to map everything. We just want to map something that's typical. So the example we're going to look at is what's called the guest cycle in hotels. I know nothing about hotel software, by the way. I use it a lot in examples, but I know nothing about it. So take anything I say here as with a pinch of salt. And I apologize if you do work in hotel software. But the guest cycle is this idea that I want to book a hotel. I do some research, book a hotel. I book my room. I turn up on the day. I check in. I stay in my room. Maybe I use some services like room service or the minibar or bar downstairs, and I put it on my room bill, and I check out at the end and I get my bill and I'm done. That's called the guest cycle. And things like that are what you want to model, right? Traditionally, we tend to think of there being two types of processes. There are essentially the kind of customer-facing processes, which are how we actually deliver value to customers, and there are organizational processes. How do we support parts of that process of delivering to customers? So there'll be a whole lot of organizational processes, for example, around how do we support basically getting you food and drinks and beverages in a hotel as a customer, right? But we're only going to try and map a small part of it in one go, so we're just going to map the traditional guest cycle. So you have a kickoff, right? Now, then what we want to do is basically walk the process. So traditionally in kind of industrial value stream mapping, this is called go to the Gemba. You actually go to the floor and walk the actual process and see what happens. In software, that may or may not be viable for you to actually go to the floor and walk and see the process actually in action as a kind of manual process. Maybe it is. But at any rate, what you then do is return to a room when you get a large surface area and you stick some post-it notes on it and you try and say, what are the individual processes in the value stream? And when you are looking for processes in the value stream, what you're trying to seek are that as you move through that particular journey, where are the kind of handoffs? Where does essentially some element of time occur, which means someone says, I'm done with this, and now effectively the next thing occurs in the step, and there's some kind of handoff, right? And typically in a value stream, you're expecting to see somewhere like 5 to 15 processes, no more than that. You get too many more than that, you are going to granular and you're in the realm of activities and tasks, which we'll come to later. So, having got that idea of what basically it is, you go and stick all these post-it notes in a room, map the layout, and figure out exactly where you are. So here's an example. So at the top, I've got the customer. This is the person this particular value stream I'm mapping is for. And I'm going to start with some idea that effectively I'm going to do some research. I'm going to booking.com, or I'm going to the hotels and website to see where I can book a room. Maybe I want to stay in Oslo and I'm determining what hotels Radisson has got available for me to stay. Then essentially I'm going to make some kind of booking, right, as the customer. I'm going to make a booking and say, well, I'm going to check in to Oslo on the 20th. Then at some point I will actually turn up, right, and check in to the process. I can't read my own slides from this distance. I must get new glasses when the lockdown ends. Then I occupy my room, right? I go into my room and I say I'm staying there. And then there's things I may add to my bill by using the mini bar, right? I may decide that Toblerone bar and that box of Pringles looks particularly attractive when I come home after having drunk a couple of beers. Can't afford more than a couple of beers in Oslo. But I basically start to run up a bill, and then at some point I will actually check out and be presented with the bill for my stay, right? Okay. Having done that, the usual advice is to do a second walk. And in the second walk, what we do is we go back from the process from the rear and we say, okay, let's figure out how I got to the artifacts at the end from what happened at the beginning. So in our case, I could essentially decide that I'm going to go back to a bill, right, so that I am receiving as the customer at my checkout, and figure out how did all those line items get onto the bill, and how did I then, when I get to the point of check-in, etc., how did I create a reservation? We walk the whole process backwards, and that's really useful. A lot of insight quite often comes out of looking at the artifacts and figuring out how those artifacts were presented. It's interesting, I was watching Adam Dimitrich's talk yesterday on event modeling, which I found reminiscent of some areas of structured analysis by Jordan. And it's essentially going back to this idea of saying, look at the artifacts, look at what's produced on a report or something at the end of the process, figure out how those data elements got on there. What was the process step that made that happen? And then we map details. So at this point, essentially, we should probably, as we do the second walk, in a traditional value stream mapping process, we begin to figure out timings. How long does this section take? And people are looking at essentially lead time and process time. So lead time is how long do I have to wait around doing nothing. And process time is how long actually does the processing take. So if I think about the example of ordering a coffee at Starbucks, the process time are things like how long does it take the cashier to take my payment? How long does it take the barista to actually make my drink? And the lead time are things like how long am I waiting in a queue in order to get served? Right? How long am I actually then waiting behind other customers at the end of Starbucks essentially to then get my drink? And those are all lead time elements, and waste is really reducing a lot of those lead time elements. Okay. So we have something like that marked up with effectively those things like lead time and process time. Also, we might mark up things like number of staff involved in the process, etc. And someone can draw up this, which is essentially a value stream map. And you'll probably find on your drawing tool of choice, though you've never noticed it, you have a tool for drawing up a value stream map. And the value stream map shows the individual processes, and it shows essentially the time that it's taking to complete those individual process steps in our value stream. Okay. When I have one of those, what I care about really is this, right? That's a process. And that's a key target for me to think about as a suitable partition for a microservice. So really, I can simplify this and make it look a little bit more like traditional process mapping and say, actually, those are my candidate processes. Once I have processes, I can take it a step further. And that's to think about the activities and the tasks that occur inside those processes. Sometimes a process is too coarse-grained a target for a microservice. And there are a couple of reasons for that. Usually the reason is that I decide that check-in has a lot of software that I need. And one team can't move fast enough for me. And I want to enable 3 or 4 teams to work on check-in. But that would create a new monolith around check-in if I needed 3 or 4 teams to work on it. Even though I might say I have a microservice, I'd have monolithic microservices. So what I can do is drill down to the next level, activities, break up my check-in process and say I'll target those as my microservices instead, because I need that extra level of granularity. And you quite often find that there can be synergies amongst some of my microservices, right? That essentially they're saying, well, some of the activities are common across a number of microservices. There are some things that can happen here. One is we've genuinely discovered that there is value in breaking down to an activity level, because this given piece of work is actually something we want to model as a separately deployable entity with its own backlog. We may also be in a DDD problem of, although it looks very similar, actually they're separate bounded context. They have slightly different information and requirements, and really we're just going to absorb that activity into our service because it's actually slightly different. And one of the things to avoid is building entity services rather than process services. So if you find yourself as a result of some of the mapping breaking down your processes ending up with a top, where essentially your microservice looks like a CRUD wrapper around an entity. So it looks like a CRUD wrapper around a room, or a CRUD wrapper around a reservation. And all of the logic has to now float up into some kind of orchestrator. Typically, you built something at kind of a gateway layer, or maybe you built something in the first service in the chain that actually has all the business logic, and all the services effectively have feature envy because all the logic's drifted from these simple CRUD services into this orchestrator. And this is essentially the enterprise service bus problem, right? And you get that as soon as you start building entity services. What you want is to get something closer to the bottom, where those clear handoffs that were occurring between our process steps can be simulated by events, probably being raised between the individual processes that contain the data from the first service that the second service needs to do its action. But individual business logic related to that process is contained fully within the microservice. I mean, that's a link to a great article by Michael Nygaard, or a couple of articles basically, where he discusses the entity service anti-pattern in some depth. But people have mentioned this for a while, right? So people have talked even in the SOA era about CRUD-based SOA or CRUD-based web services as being an anti-pattern, and this is kind of why, right? You want to focus on processes. So obviously what happens with rinse, lather, and repeat, right? We don't just have one value stream map. We have many value stream maps, and the combination of those helps identify processes that we need for the whole organization. You can get a kind of leg up. So organizations like APQC in the US produce standard maps across industry sectors, and those maps can give you a starting point where you can say, hey, well, this is kind of similar to what I do. I can take this map and begin to use that to get an idea of how to do the process map of my organization, and I can target microservices against those, because you may not have the funding to go away and do a full value stream mapping exercise across your organization. Value stream mapping is kind of really common in industry. A more common one for us to think about is event storming by Alberto Brandolini. Slight aside, Alberto is now famous in France because he also came up with Brandolini's law, which is that the amount of effort required to undo bullshit is an order of magnitude greater than the effort required to basically create it. As some French doctor being interviewed about the pandemic mentioned Brandolini's law, so Alberto has basically been famous on the news. There's this idea that we can essentially build a model of our system using events and some key components. Now, I don't have time to teach you all of event storming. Here are some of the key artifacts. We focus kind of on the idea of an event, the orange sticker saying a domain event. And an event is essentially the result of an action by a command on an aggregate or an external system. And we can use some of those events to help decision making by individuals, which may result in new commands being issued to the system, which may raise events through the action of some kind of policy, so code running with some business and domain logic inside. How do we model all that though, right? So the first thing we do for event storming is a thing called chaotic exploration. We stick a whole lot of post-its on the wall that represent what we think of as the key events that are occurring in our given customer journey or stream that we are mapping, right? Event storming is a little bit less defined about exactly what your target is, but again, you need to define a target. What are we trying to basically find the events inside? You stick them up on a wall and you end up with something a bit like this, right? Don't worry about reading all of these things too much. We just run through something very similar, and they are probably wrong. But the idea essentially is I've got a similar model here, right? Effectively, I'm talking about checkout, but maybe I've got some extra elements like reservation timed out and another path, and I've got things about basically issuing keys, etc. So a bit more detail than I may have had in my process map. And the events represent things that happen within the system where essentially data is generated, right? And again, you can think about them as often key handovers in the system. So we basically organize that into a timeline. Once we've got it into a kind of left to right timeline, usually, Alberto's got a book that explains different options for producing timelines. We then go and add systems and people. So now we essentially have yellow stickies that represent actors. We've got guests. We've got essentially someone working on the checkout desk, for example. And then we've got commands in blue. So someone issues a command against an aggregate, which is a big yellow sticky, that results in an event, which is an orange sticky, right? And we've got some external systems for interacting around email and payments here as well. Okay. We do a walkthrough, so typically somebody stands up at the board and describes how a customer books a hotel room, and we change and move events around and a part of that process. We get a nice fully done timeline. And then much as we do in value stream mapping, we then reverse that and start at the far end and walk back and say, what raised this event? Okay, what caused that command to be issued? And that then gives us essentially a complete timeline. Okay, so given I've got this complete timeline, how do I find microservices? Well, the object of event storming is not to find microservices for you, but it does give you a couple of clues. The first thing is you can begin to identify these aggregates, which is data that we're storing. Now, we don't want to build entity services and we just focus our microservices solely on aggregates. We may end up with that. But here you can see we've got a number of places that we're dealing, for example, with rooms, with billing, with the registration. So it may be possible that there is a microservice runs around billing or registration or rooms. Okay. What we want to watch for, again, is this problem that DDD describes as a bounded context. Right? It's quite possible that the billing the rooms we're dealing with at checkout is not the same as the rooms we're dealing with when we're making a reservation. Maybe we're recording quite different details about that. And although they will share something like an identifier, they may not actually be the same data. And so it doesn't necessarily push us towards putting them inside the same microservice boundary. We also typically tend to find microservice boundaries around where events are raised from one item to the other, but you can raise events within inside a microservice. Don't forget that much as a monolith can be a distributed system, so can a microservice, right? And this is a common mistake which Fowler and Lewis call out in their paper. They say naively you may choose to view a microservice as one process, but actually in reality they consist of many, right? And so this gives us a model where we can draw some kind of boundaries and say, hey, this set of commands and events operating on these aggregates appear to be one force of change. Over here we have others. So we mentioned bounded contexts, and I said I'd return to that, and we said essentially one of the things to watch for here is that rooms might be in different bounded contexts from each other. And the question might be, why was I suggesting that microservices, you don't find bounded context to find them, right? And we need to return to what Eric actually defined bounded context as. And he said a bounded context is a set of code bases, database schemas, and team organizations. But it's used when you're doing something called context mapping. And context mapping looks at existing state and draws a map of it. And it does that so you can figure out what your problems are and what you need to resolve. So it's true that microservices would appear as a bounded context. They have a team, that team shares some code, it shares some database schemas, it's a continuous integration boundary. As such, a microservice is a bounded context. But it's also true, and it shares ubiquitous language, right? Within that microservice, terms have a defined meaning. It may not be true that in the other microservice it has the same meaning. So rooms could mean something in our reservation service quite different to our checkout service, right? And checkout may even be actually part of front desk, right? And so maybe actually that room is really reservations. And that's the kind of thing we then discover when we're going to do some analysis, right? The problem with this model of saying just find the bounded contexts is that bounded contexts are used to analyze an existing system and not used to find partitions in our software. There's nothing in the DDD book which tells you how to find bounded contexts in a clean greenfield environment. Because a monolith is also a bounded context, right? It's a bounded context where we have multiple teams, code, schema, and maybe a single CI boundary. We might map it as a context called a shared kernel and show effectively that it's integrated with it, and there are actually a number of separate contexts in it. If teams were clearly divided into working on individual components within inside that monolith, but essentially you can map a bounded context to a monolith. So you can't target bounded contexts. You have to target capabilities and processes. And again, this is because language aside. Right, so I just wanted to kind of finish up on a little point I mentioned just in passing back there, which may shock some people, and that's that if we focus on the idea of a microservice being independently deployable, but what I'm building is something that models a process, a business process, then the number of actual containers, and I mean containers in the kind of sense of something that hosts code, not necessarily, which could be an application server, it could be a database, as much as it's not necessarily a Docker container, is as many as we need in order to automate that process. And the number of lines of code in the microservice is as many as we need to automate that process. And those size constraints do not define the boundaries. They are a consequence of the boundaries that we have drawn up by looking for the process-based boundaries or the activity-based boundaries if we need to go slightly smaller. And that means that realistically, I may have multiple containers in a given microservice. I may have the HTTP API that I speak to my web client and my phone clients. I may have an AMQP API because I'm communicating asynchronously with other microservices, and they will obviously scale differently from each other. So if I want to scale them differently, I need to have them as separate containers so I can apply different scaling. And I may have some long-running calculation that builds complex state, and I want to basically stick that in behind some gRPC container, effectively call to it from the other elements. And there may be a database, and we might even, have a file system element to it. But when we communicate between elements of our microservice, because it's inside a deployment boundary, we are open to the idea of not only using things like our messaging, which essentially tends to be low coupling, but we're open to the idea of using a shared database between, say, the HTTP API and the AMQP API, because we're inside a deployment boundary. So that coupling doesn't have the same impact on us. Right? It still has some impact. We might choose if we're releasing one thing very separately the whole time. The lack of that impact means that all of those integration strategies are open to us. Whereas between microservices, we're very likely to prefer asynchronous communication via events, particularly if we have mapped our processes, or to use essentially RPC techniques like gRPC or HTTP APIs if we have some near real-time requirement, or probably even more sadly if we haven't properly actually modeled our processes. Right. So, all in all, what am I trying to get at? If you want to see why microservices existed as an idea, it's because we wanted to become faster at getting software out the door. And the way to get that software out faster was to split our monolith amongst multiple teams who all essentially had their own product backlog, which meant that they could continue to iterate and improve their software without having to coordinate with other teams. And as much as possible, we want about 80% of our work to not involve that coordination. And the history of SOA, of which microservices is just a part, has lots of learning about how to get those partitions right so that we can have stable boundaries in the form of the API of our microservice that don't change too often and therefore don't force other microservices to re-release in order for us to release. To get those stable boundaries, traditionally we have always looked at mapping an association between SOAs and business capabilities. In particular, the microservice is usually modeling a process in that capability, or perhaps we need to be more granular, an activity within that microservice. And we find those by a number of different techniques: value stream mapping, event modeling, right? Those are ways essentially of finding our microservice boundaries. And we can use some off-the-shelf artifacts like existing process maps. Right? That will give you the ability to understand the size of your microservice, the number of processes inside it, and give you better boundaries and move you away from an entity service model into basically a process service-based model. All right, and we are done. I will take questions in Slack. I need to drink some water, etc. And I need to shut down, the video, etc. But I will then be taking some questions afterwards in Slack from you guys. Thanks very much for listening, and I hope that was really useful. Thank you.